So there we go. Hello, welcome everybody to SUSE QE Tools Workshop. See that, that's nice. So for today, the topic that we have planned is continue with the backend code walkthrough. So we already discussed the general hardware backend, and now I want to go into the ipmi backend. For that, we have a convenient link here. You just follow that. And basically what I want to do is really go through the code with you, trying to understand that very specific backend. However, I would like to refresh the general interface that we use for backend. Let's take a look into the folder. So OS Audience supports different backends. Basically, every single file that is visible here can be configured and selected as backend, though some are just all base classes. So for example, we have one which is literally called base class, and we have another one which is called null. Actually, I want to show that backend because it's so trivially easy to understand, and so it helps with understanding. So what we see here, that this is like what every backend needs to fulfill, is that we inherit from the base class. So in object-oriented programming, or backend base class is the parent from which we derive from. We have a constructor, and we have multiple methods that we need to define to be able to form a complete backend. That is start VM, do start VM, do stop VM. So basically what they do is they make the actual implementation how called VM, but it's more like maybe we can consider renaming that. So this is like the test machine object that is controlled by a backend. Start it, stop it. We have methods to extract assets, because that depends on where assets like think of an installation conducted on a machine, and you want to preserve that installation and reuse it in another OpenGate test. So this is where this comes in handy, and of course that depends on the application. Then we have the generic run command, can handle is shutdown to check if a machine is shut down, and then stop serial grab. You can actually select.
What is the can handle?
Again?
What is the can handle?
Can handle, like if it can handle something, and I think we will see more examples in other cases. I'm just saying, like, from a proper programmatic point of view, if you develop software, then don't care about the meaning, just make sure that we have an actual empty implementation. So you could actually select, when you trigger OpenGate test, you could select this backend and run tests, start tests with it. You won't come verify, it's used for testing purposes, but it will also serving as an. Now going back to ipmi, so what we see here, we have new, which is basically calling the superclass constructor, is just checking one necessary variable, which is the worker host name. So what does that mean? Well, that means we have the need to go over multiple steps here, right? So ipmi is used to control physical machines, and for that we need to go from, let's say, starting from OpenQA, the web UI instance, we would go to the worker which is running that backend, and that worker is then connecting to the target machine. And so that we have the possibility to connect to the worker in that case, which is in the middle. We need it to be explicitly defined. So the backend needs it, but if we Let me just look up in code locally so that yeah. But what we try to do is that we automatically define that worker hostname. So I think OpenQA sets it then. So, but if you start OS orders manually, then you set it like the FQDN of the. Then we have a function which is called ipmi command line. This is a smaller helper function which is used further down. But this is where you see that the actual ipmi commands are executed. First, again, what we do is we check for the variables that we need, and there are 3 variables we need. We need to host the, so this is all with the prefix ipmi. We need ipmi hostname. That's the actual SUT, the system under tests, the target machine that you want to control over ipmi. For that we need the ipmi hostname. It says hostname, so it's generic. It should be a fully qualified domain name. It can also be relative one if that's reachable depending on network configuration. It could also be an IPv4 or IPv6. And then we need the ipmi username and the ipmi password. So, like if you have a pristine machine, you just get out of the box. In many cases, it's something like capital case admin or something. But of course, for security purposes, depending again on the network configuration. And then what we do is we actually return the combined command. So this is ipmi tool, the same thing that you would also be able to call on a command line. And then it's concatenating these arguments, including, and then in the end, we have username and password. And this is then used later on where we actually call the command. So ipmi tool, this is where we use that helper. So you can see already it starts with defining tries, and meaning it's possible to try multiple times. So this is helpful if you have, in particular with ipmi tool, sometimes for various reasons the command execution fails, but then is executed correctly on retry. And rather than handling the retry on a much higher level, like retrying the OpenGate job or installation, what you can do is can use this this tries parameter. What we then as is we gather this command, which is basically it's an array. So we have this array where we have ipmi tool and all these parameters concatenated, and then we append the actual command for ipmi tool, something like power on or stall activate to get access to the serial over LAN session, which forms then this command array as a component, including the. And then what we do, we call ipmi tool and we save types for standard input, standard out, and standard error. And what we get in return is a return value. So yeah, we already have seen tries. So for tries, we walk over that, and then we call ipc run. And what you see here, ipc run is actually that we fork process. Sorry, we don't. Or is it fork? I guess it is. Yeah. So we execute another process. So ipmi tool, which is part of that command, is actually run as a separate process. And what we put in is our standard input, where we actually never put anything there, but we save standard output and standard error. Yeah. So we have this funny loop here. It says if return equals 0, so if that was successful, then we call del sleep and last. And actually, what is del sleep? Let me quickly look that up. I'm pretty sure it's something Very simple. Oh yeah, right. So it's defined further below. Del sleep effectively is just another sleep for if we are on ipmi hardware Dell. Okay. If the result, and then we end the retrying loop. If the result was not successful, then we sleep for another 4 seconds. Honestly, this looks weird. I would rewrite it. It could be simplified, but in the end, it's not that hard. So nobody changed it yet, though it's trivial to do. Then we jump the output from the two pipes, the standard output and the standard error. So jump means that we remove any additional unneeded new lines. And then what we do is we basically what it says here, output the error message with ipmi password mask. So what we here is that we taking the standard error output, unless red, meaning only in the case of actual errors. But what we do there is whenever we find a string that matches the ipmi password, replace it with mask. So the ipmi password won't be leaked into the log file. Additionally, as a debug message, then we output the standard output, which we also read. Del sleep we have seen, so that's basically just additional sleeping. So probably you know that from me when I'm reviewing code that I'm trying to point out that sleep is almost never the right thing to do. Maybe when we actually do retries like here, then I would say, I mean, that's fine. Maybe that could be configurable, sure, because we retry for various unknown reasons. But when we are talking about a known thing, it says Dell BMCs are touchy, then yeah, maybe it would be more beneficial to understand the real reason. But it's allowed, it's fine, and in the end, this is how it keeps stuff working for years. So, if it helps automating tests rather than executing tests manually, why not? Now, next is restart host. So this is not one of the backend API functions, but I think it's another helper function. So yeah, we can see that, for example, it's called here. Let's go over that. So here as well, we use multiple tries. Then we use self ipmi tool chassis power status. What does that tell you? Well, that tells us is the machine on or is it off or another unexpected status. If it's not off, then we set it to off. And then we wait a little bit. We check the status again. And then we want to really make sure that it is off. And this is basically retrying multiple times. Like if that fails or takes longer, then we retry and we wait until the machine is really off. And then afterwards, ipmi tool chassis power on. And then again, what we do is like the inverse. We really want to ensure that it's on. Now, why all that? Basically, there is also power, the ipmi tool supports power cycle and power reset. The reset is corresponding to a soft reset. It's like the reset button that you have on a PC case or on a computer case where you click that button and then it just resets the main board. There is power cycle. Power cycle is actually doing what this one should do, which is really making sure that power is like, this is the equivalent to you pressing the power off button or the AC power button until the machine really turns off, wait some seconds, and then turn it on again. Why this implementation and not just ipmi tool power reset? Honestly, I don't know. So we can check the Git history later on maybe, and we can also talk about suggestions and improvements. But let's first walk through what we have in the current code. Then there's do start VM. So this is an actual implementation of one of this backend API functions. So every backend needs to have an implementation. So what it says, it's reset ipmi mainboard if switch on. So what we do here is we reset the component which is actually used for the remote control. Okay, so we are asking over ipmi this this out-of-band controller to reset itself, which can help because sometimes there are various problems, and it was found by testers that it really helps if you do that first. So yeah, okay, fine, then it's done unconditionally here and not on error. I mean, there's always the question of a design choice, like should we really only act upon problems if they happen, or should we prevent sporadic problems by always doing something like this when it helps? And so the latter is the case here. Then fine, it would need, because we're talking about the ipmi backend, so be really sure about changes. It would need a rather expensive and longer testing, so that you would need to run like multiple hundreds of tests at best on multiple different machines, because ipmi also does behave different by machine, to really understand we can improve the approach with a changed patient. However, this is controllable directly by test variables. So by default, this actually doesn't do the reset, but you can set that variable. And then it does the restart of this control component. Similar, we are just talking about starting VM. Similar, the actual restarting before we do that. So the actual implementation we have seen before, which means we power it off and then we power it on, and this takes some seconds, so it's taking away some time. This can also be avoided with ipmi do not restart host. And I'm pretty sure that this was also added later. So initially, maybe it wasn't there, and then this elaborate function was done. And then later somebody says like, oh, under certain circumstances, we do not want it to be restarted. So yeah, that can still be selected. Then it does truncate serial file. I don't know what that in particular means. We will do that later. And then it adds a console. And that's an important part. So for various backends, we have various consoles that make sense to connect. Remember about the Chemo backend, or think about the Chemo backend as an example to which we compare. In Chemo, you have a virtual terminal, and you can directly see the output of that, which is like TTY1 or TTY2, and connect to that. And then also we tell the backend what console that is, so that OS audience knows which commands, what methods to use to actually change between consoles. So in Chemo, you would do the same as with a physical machine. If you have it like in Word Manager, you would press Control Alt F1 to switch to TTY1, or you would press Control Alt F2 switch to TTY2. Now for ipmi, for this remote physical machine that we want to control, we do not have that. Right? What we do have, with the help of ipmi tool, is the so-called SOL. That's short for serial over LAN. And that means that if you would do that manually with ipmi tool, you would call ipmi tool SOL activate, and that would connect to the first serial terminal of a machine. So within the actual SUT, that's could be, if you have a Linux operating system installed within the SUT, that would be TTY-S0. And depending on what the operating system is providing on that TTY-S0, you would see an output or not, and you would be able to control the machine or not. So, for example, if you start the OpenSUSE or SLE YAST installer, then it will provide a way to interact with the YAST installer on that serial terminal based on the configuration that you selected. In the installed system, normally you would have a getty, which means there's a login prompt, something like machine name, blah, 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 login, colon, and then you could log in over the serial terminal, right? It has some limitations, but it's actually something that admins, including myself, use in their daily life. So think about a machine which we are setting up, and we do not have an operating system installed there yet. What we do is we connect over ipmi and then can instruct it over the serial terminal, maybe in a manual fashion, maybe automatic, to actually get an operating system installed. And this one takes additional parameters. So for example, a persistent ipmi sole persistent console. What that parameter means is that if we reboot the SUT, right, then the console should persist. So, if you press the reboot button, you can still look on the physical screen of a machine. In the case of ipmi, if we call power reset in one terminal, in the other terminal where we call sole activate, you can still stay on the terminal. It will persist. So we do not need to disconnect it or reconnect or something. Just to compare it to another example, and we are talking about remote virtualization backends where we start a VM and we connect to the SUT over SSH, and the SSH server is provided by the SUT itself. Then, if you reboot the SUT, the SSH connection would disappear. So that would not be a persistent console. In that case, you would need to instruct OS audience to reconnect whenever you start or restart the target machine. But here, for this terminal, it is not. Then we have log. As you can see, by default, it says don't log. Honestly, I don't know what that means. I guess it's like recording a log of that terminal, and by default, maybe it's not. I don't know why that's selected as a default. Interesting. But it can be configured with parameters from the test. So you can also, experiment without needing to change the backend with the existing tests when you have an OpenQA instance that has a worker fulfilling that backend setup. And then we tell this console that we have created about its backend. So that we tell like, hey, we are the ipmi backend. We are creating a sole console. We are telling about the backend. Okay, that's the start VM methods. Of course, the corresponding equivalent would be the do stop VM, which is actually much simpler and straightforward. So first, what we do is we actually ask the SUT to power off, unless, and again, this can be controlled, this corresponding to do not restart host, we have ipmi do not power off. And then we have deactivate console, where this one stall which we created up front, we would deactivate if it's actually defined. So, it could be that we're actually calling do stop VM in a case where do start VM wasn't called in before, or maybe we have multiple do stop VM calls and then the terminal doesn't exist. The console doesn't exist. That's fine.
Oliver.
Yep.
do start VM doesn't start the VM, right? It just connect the console to the remote machine.
It actually powers on the remote machine here by default.
Okay.
So I know it sounds a bit weird. So multiple contributors have changed and patched that file, and the idea is walking through the code, which also gives me and you and others ideas like how can we improve it. And I think this is one point for improvement, because it says restart host. This could be just renamed. I mean, not changing the logic, but just renaming it, because what this restart host is actually doing is ensuring that the host is on afterward, unless it was selected to do not restart the host for whatever reason. So by default, yes, it does switch on the target machine. And by default, SUSE stop VM actually powers off the target. There is shutdown. This is one you could say a getter method. So it's actually not changing the remote machine. We are just asking it for the power status and then telling is it off or not as a Boolean return value. It doesn't do any action, any more action. There's check socket. It's checking if you have SSH serial or is relying on the base class method. Yeah, I can't tell you more about that. If anybody knows what that means, yeah, feel free to chip in here. Then there's get MC status. We have called that, for example, here into start VM. And what this one does is asking some information from this ipmi controller, and also conducting a self-test unless it was selected to skip self-test. So what we can see here is that multiple different people with different test scopes in mind, different use cases in mind for that backend, came up with an approach here. So just a quick glimpse into Git blame. We can see that in this case, Michael selected to add conditional skipping of ipmi self-test. So apparently there's use case where we don't want to call the self-test and then self-test. But originally 6 years ago, SysRich thought it's the right approach to actually conduct the self-test originally unconditional, right? But besides that, there were not a lot of changes. Okay, sorry about it. There is this MC reset function, which is a bit elaborate as well, which you can see this is actually the most complicated function in here. And what this does is, I don't know if MC does it stand for master controller or anything, but this is the ipmi control. It's not the system under test itself where you want to install the operating system on, but it's the component to which we connect using ipmi tool. And what we do is, if we want to reset this console, so Michi, thank you for that note. So this variable was added because different machines behave differently, and I completely understand that, because this is also my experience. I mean, ipmi is a standard, but still the exact behavior, in particular when we're talking about thousands of automatic tests that we run in a row, some machines behave different than others, and this is causing problems, like taking too long, causing weird timeouts or anything like that. So this is why we do it like that. And then MC reset. So first, if the console is defined, then we clean that up and we make sure that all that is separated from the point of view of auth audience before we call the actual MC reset. Why is that? Because that would terminate the serial overland session anyway, and it's cleaner and is preventing problem if we do that explicitly. Okay. First, if there is any connection to the serial overland, then we deactivate it and terminate it properly. And then what we do is, again, with multiple retries, we call MC reset code, which is, let's say, rather harsh reset, because there's also MC, as you call it, MC reset form, I guess, or hot. And let me check in the command line if I can. Yeah, okay, I don't know. Doesn't matter. So this tries to call a cold reset of this controller. And if that was successful, then waiting some time before we try to reconnect. Why is that? Because, well, after we reset the controller, it's actually not even reachable over network, and it will even, I think it does request a new address over DHCP if it's not statically configured. So it makes sense to wait some time and try to probe connection with ping. And this is what is done here. So first we wait a bit and then we ping it. I would say probably wouldn't harm to start the ping with some waiting time in between immediately anyway. Doesn't matter. And then we just form the ping command here, and then we execute it within here. And if that did not cause any error, then we assume that this ping check worked, and we can check that ipmi tool can connect to the remote instance. We do that with chassis power status. Actually, we do not care about what it returns, just that if we can execute that command, then we can assume that the ipmi controller is fully accessible again. Additional sleeping, because ipmi, and then, yeah, sorry. Normally we would return here. It's only additional sleeping between multiple level of retries if that failed. So, yep, this is where we exit the do MC. Now, do you have any additions, corrections, or questions? Doesn't look like it. So give me a second, and then I will check if I can find a good example. And then let's go over an example where we would be able to see how that looks like in reality. Another browser instance and example. Anybody has an example of Engage job ready that we can present? But I'm just wondering, what's the machine called that we want to? Do we have any ipmi jobs on OpenK? I don't. Orbit. Okay, in the job groups where we originally had. Oops. Can't have anymore. I guess Then use. Okay. So let's try here. So this is a job about virtualization, and this is why it makes sense for some of the tests to use a physical host and try to set up a virtualization hypervisor. This one is using backend ipmi, so we can see the actual backend that we talked about in detail. What we find here in the auto-inst log, actually let's first check the variables. So we have, yeah, right. So you see, for example, that we have the ipmi hostname set, we have the ipmi user set, the password is also set. It's just not shown for the purpose of security in this variable, in this variable file. So those are the simple prerequisites that we need. And now if we take a look into the auto-inst log, if we, okay, let's start with that. What was the first one? Right. So we see the test is starting here, loaded needles, and then the very first output mentioning ipmi is this, was it called get MC status. So with get MC status, we call MCGUID, MC, and then self-test unless that's skipped. So that's what we see here. We have the system GUID and some warning about the ipmi specification violation. First, we see that this is a super micro machine, and then we actually conducted the self-test. We can see that it passed. What you can also see from the timestamp is that in this case, it took 4 seconds to execute the self-test. So I would say also not negligible, but fine. Then after that, there's quite some waiting. So 12 seconds kind of wasted not doing anything. Why is that? Because, well, there was this sleep after MC reset to make sure that at the very least we sleep for 10 seconds. And then afterwards we check if the control is reachable with ping. And then what is done is the power status is checked. So yep, the machine itself is off. And then it's asked to turn on. And then when we check, it says is on. And then we have from the backend got go. That's a message that's like a generic message. You would see the very same in Kibo. And then we can connect to the machine over the created console. Keep in mind, there was a single console that was created called Soul. Yeah. And that's the only interface to the machine that we have so far until later we can create more. So this is why now this test module, so this is from the test distribution and not the backend itself. It's called select console. So the soul is selected. So that would be corresponding to you typing in ipmi tool soul activate and then taking a look on the output, and then you can type something on it. So what is done here is that it's checked what is on the screen, looking for the Pixie boot menu. We can see looking for that. And it found QA net selection ipmi tool. We will see how that looks like in screenshot soon. And after we have that, then it's calling send key until needle match. So actually, then we can press keys and we can interact with that serial terminal. Command is typed in from which target you want to boot the SUT. If we go further, then we can see more mentions of ipmi. You can see that there actually has specific helper functions in different cases. For example, here get installation. I don't know that function, get installation partition, ipm backend utils. Yep. Let me see, is there anything more interesting? Yeah, no, okay. This is then too specific. Now I just wanted to go with you over the screenshot. So how does it look like? This is the actually very first screen that we looked for. So this is the serial over LAN session. You can see it looks a bit weird with this mouse cursor here in the middle and still not completely rendered menu. So this should give you a hint that this is not like a directly connected physical terminal, and this is also not the same as TTY1 or TTY2 emo instance, but that this involves multiple steps of connecting over that. So in the background, we do have ipmi tool soul activate running, which then gathers this output from the target machine, and we get from there. Here you can see this is where the menu is completely rendered, and then the automatic boot is aborted, and we get to this boot prompt, and then on this prompt there's a lot of typing happening. So this is typed manually over the serial over LAN session. Likely this is also done in a, rather slowly, because that emulation of serial terminal over LAN can be is not as stable as you would have a direct physical connection or a true serial terminal. And then eventually yep, so this is the last time we take a look on the serial over LAN session. So the installer was started, and the installer is telling that the installer itself is reachable over SSH because of the parameters that were selected in before. I think we can see SSH equal 1 and the SSH password. So this is why the Just installer is telling us you can log in and then run Just SSH to start the installation and the network interface for additional. Well, we assume we know how we can reach the system. So this is why in this step, this is a new console. Okay, so we are kind of switching from one window to another, and this new window here is telling us, warning, permanently added this static host name to the list of known hosts. So this is a warning that you get from the SSH client, and then it asks us for the password. Well, that's the SSH password that was just set in before. If we continue here, then we will let's scan over SSH. Then yeah, I think this is the same terminal. So this is the YAS terminal. Of course, we could use something like X forwarding from SSH, which is also done in other cases, but I don't think we see that in the setup using ipmi. And when again would we interact with the ipmi sol? After we trigger a reboot. So that's the end of the installer. And now, of course, you can just hope or assume that after reboot, the SUD would come up and you would never need to interact with the serial over LAN session again. But as the machine might fail in various steps on boot up, this is why it's actually checked what's happening there. So this is also helpful for debugging purposes. So this is again the serial over LAN session where we see that. I don't know if the hardware boot entry is explicitly selected to boot or if it's just waiting for that to boot automatically. But doesn't matter because in the end we see this boot up screen. So again, what we see here is the terminal view over the serial over LAN session. You can also see that mentioned here. It says TTY-S1. So this is a serial terminal, and the serial console is connected over ipmi. And after we again see that, then we know like, okay, it's more comfortable to connect over SSH and then work with the target machine over SSH. If you have manually worked with the ipmi serial interface, I think you can confirm that it has some quirks and some limitations. And as soon as you have SSH, that's again more comfortable. So OpenGate just does the very same thing to say, we will work with a SOL if we have to, but if we have another mean available, meaning SSH, then that will be used. Okay. Anything from you guys?
The IBMI use always Pixie to install the system, right?
Okay, good question. So in OS audience distri OpenSUSE, the main test distribution for OpenSUSE and SLE, this is the only way which I saw it being used. Okay, but the backend itself doesn't prescribe anything about what you do with a system. The backend only brings you to the point where you say, I can power on the machine and I connect over SOL, and then I see what's going on. You can use that, then again, it's depending a bit on the specific machines. You could use other means like instrument the menu that you get from the firmware of the SUT, and maybe it gives you UEFI menu where you could directly boot from a remote source, or use the menu to access a boot menu over network in another way. Or maybe you have something physically connected, like a USB thumb drive, the physical machine, and then you just need to select that entry. That's all possible using backend IPMI, because again, the backend is only on a lower level. Okay. Okay. Anything else you would like to ask or note about IPMI? Anybody sees points for improvements? I see points for improvement in the actual the code style, maybe a bit of the logic to save some waiting time while, not necessarily forcing a sleep, and in the end you don't need to sleep, still supporting a sleep where it is necessary to work around quirky hardware, but it's probably not a priority. And also we don't have current plans within the SUSE QE Tools team to work on this backend or other backends. There is a certain, we do have unit test coverage for this file and all the backend files, but there are certain things like, again, this timing specific behavior, which I mentioned. To be sure, you would need to test it out on multiple machines. Yeah.
Maybe you can show us the how worker configuration.
Again?
Maybe you can show worker configuration.
The worker configuration?
Yes.
Right. Okay. So let's take the latest example. So this was working on Grenache 114. And what we see here as properties is that we have the worker host name set, which the backend says that it would require. And then the actual, let me quickly check the actual configuration, which we have in salt pillars. -1, and then what? Okay. Second. Just masking something there. There you go. So this is how it looks like in our salt configuration, where we have the worker class. So basically what it says is multiple things fulfilling with a component name. Then we have the ipmi host name. We have ipmi password, not the real password here. We have the username, and we have the SUSE IP. I don't know what we need the SUSE IP. But that's it. There's nothing more. Actually, SUSE IP is never defined within auth audience, so that's required by the test. Because if you look back here, as soon as we switch over to the serial terminal, we connect to 41 QA SUSE QE. So that's the SUSE IP. Okay, that's it. There's nothing more about config. Okay, anything else?
And where we can find the password?
In salt pillars. Yeah, you have access to salt pillars repo, I assume, or you should be able to. I won't show it here on the stream. Okay, cool. So that's about that. That was the ipmi backend. We do have other backends that we can look into. The next meeting will be on the 5th of May, which is again the beginning of a new month. And this is where we can have the new roadmap. And there are some shiny new stories which I'm looking forward to walk over with you. This is after we needed to skip due to the Easter break in April. So the last roadmap was actually there's a gap of 2 months that a period of 2 months that we can cover. And after that, the current proposal is to do a walkthrough of swords.pm. It says to be defined because I'm certainly not an expert there, same as I'm not an expert for the ipmi backend. If there's anybody coming up and says like, yeah, I will do that walkthrough, you're welcome to do so. Please contact us, and then I can sign you up for that. And if not, then, well, I will give it a try and walk over that together with you. So that's it. Until next time, thank you and see you. Goodbye.